manufacturing, technology, hot topics, and a little bit of tomfoolery. This is the MTD Podcast.
Oh, there you go. That was a bit abrupt, wasn't it? Podcast 15, metrology. Welcome to myself, obviously, Colin Griffiths. Paul Jones is not here, so we should have a good time, lads. Mark Deadman, Joe Reynolds.
Tomfoolery, no Paul Jones or Giovanni.
Yeah, Tomfoolery's back in the room now. Thank you, Tom, for joining us.
Plenty of food in the fridge.
Joe's
Paul's out the building.
Absolutely.
We can see everybody above the actual table.
Now then, lads, I'd like to say, Joe, you're in charge of the buttons. This is not dubbed applause and stuff like that. So, there you go. Thank you. It's all in the timing. What I would like to say, though, I'm not sure this programme is going to measure up. Come on, hit the button, because it is.
What was it?
No, I think a big clap for metrology.
And inspection.
Metrology and inspection.
Yes,
right.
very much
so, Mark, you seem to be the man who knows it all about nothing.
Well, yeah. Where do you start with metrology and inspection?
I don't know, but hurry up though, please, mate.
I suppose the myth over the years has changed quite a lot. I think metrology and inspection used to be the last part of the process. You know, do we really need?
It normally is, mate. They've got the billet, they've made the part, and they have to measure it.
Well, I disagree with you nowadays.
Come on, Joe, hit those buttons.
You can.
Wrong.
You can actually measure in the machine while you actually after cutting to a certain extent.
Told me that, didn't it?
And also vision systems, but we'll come on to that. But
didn't see that one coming.
I think personally, the way the perception of the marketplace with metrology and inspection is far beyond it used to be, and spending a lot more money on it. It's more sophisticated. It's not just about, for example, and I'm stealing the limelight here.
Yeah, well, hurry up then.
CMMs versus scanners, handheld scanners.
Right.
Okay. Why do you still need a CMM when you've got a scanner that can actually scan your and you can take the scanner to the actual product? Well,
one thing as well, CMMs, you go to a lot of engineering machine shops, CMM tucked away in the corner gathering dust.
Yeah.
Controversial, Colin.
It's true. I won't name any engineering companies,
It's a valuable part of the machining process.
I know, I totally agree, but a lot of them just sits there not being used.
Yeah, on Mark's point, the 3D scanners, it's not a technology I'm particularly au fait with, but I know they are not as accurate as a CMM. Oh. So if you want...
I think that's controversial.
I disagree with that.
Yeah. Really?
Yeah, we're going to have dust up in a minute.
Well, no, but in my head, CMM, temperature controlled room to less than half a degree, you can measure in microns.
Yeah.
If you're taking a handy scanner onto a shop floor, opens up lots of variables, a part can grow 10 microns in the heat. So, okay, you could argue you have a scanner in a temperature controlled room, but I don't know why you would. To me, it's great. You measure certainly, like if you think of a Courier big machine, Courier or various other ones, doing big mould work, it's perfect, isn't it? You go and scan it. Yep. Yeah, that's right. Yeah, nine times out of 10, that probably will be adequate. But you do find a lot of people, they measure in the machine, whether that's with a scanner or probe, and they still get final authorization, if you like, from the CMM. But to me, the two coexist almost at the moment.
You're talking hand scanners. You've also got the scanners like a CMM, though, so pop your
I mean, people like
Creaform
probably lead the marketplace based in Canada. You know, they've got some fantastic. They've got a handy scan. They've got a Metra scan. But I disagree with you about there is going to be a dust up tolerances, because they reckon that their software can actually take in the calibration of where the actual part is that you're actually measuring.
So it takes account of the actual temperature, and if you go out to the machine shop.
I'm not. I don't know too much about the actual system, but
that's becoming clear, Mark, I'm afraid.
But what I'm trying to say, I went to one of their customers a few years ago and reverse engineering. Yeah. Now this guy. Is
that the name of the company?
No. He takes people's classic cars who race them. There is only one of them. There is no drawing, so therefore he uses the handheld scanners for reverse engineering.
See, to me, that's perfect. The perfect application.
Yeah. And you don't need it. Not saying they can't do micron tolerances, but those sort of parts on a car don't need to be micron accurate, do they?
Not on your car, could get stolen.
Yeah.
Lads, let it go. All right.
You know,
we keep mentioning that.
Well, I disagree. In an engine, probably yes, but as I say, if it was another part of the the bodywork or whatever it may be. Obviously, the tolerances are a lot higher or lower depending which way you look at it.
To me, if a handy can, yeah,
handy
scanner,
that's what you were drinking from last night.
If a handy scanner works, you'll see them in the machine tool being tool changed, because if they do work, you'll inspect it on the machine like similarly you would with a probe, and you'll get a yes or no result. And if it's a no result, the machine will change the offsets and it'll machine it until it's correct.
But they have something like that. I think was the eye scan on the Anker MX7 Linear, because I videoed it. It's Timtos. Does anybody know that I went to Taiwan the other week?
No.
But they had the scanner. They had the scanner in the machine measuring the tools once it had been ground.
Yeah,
so,
that's correct. Yeah, like you say, is it eye scan?
Eye scan, I think. Yeah,
eye
sure
scan.
it is,
Yeah. It's different technology, or is it? Is that not a camera? Is that not a camera
vision system?
It is.
So it's not a scanner then; it's a camera.
Guys,
it's a vision system.
I guess the name scan would tell you it's not a vision system, but it does look like a camera to me. Yeah. But anyway, so to me, I don't know. To me, as a handy scanner is a handy thing to have, but it's not replacing my final inspection. I might be wrong.
Yep,
you
are wrong.
I am wrong.
Okay. Yeah. But
so
it depends on the application, obviously.
Gio's here, application specific.
I'm not going to say it's his word, but you can take a CMM. Mm-hmm. You could take like the hexagon arm, for instance. Yep. So therefore, I've been to a well-known British motorbike manufacturer that actually uses
Triumph, Royal.
No, that's Bras.
Maybe, but they're actually using the arm because they can get round the bike.
Right, so but that's a probe though, isn't it?
Yeah. So therefore, you're getting very close to a CMM, and the the sort of dynamics of what a CMM can actually bring outside of temperature control. But if you take something like the creoform scanners, for instance, apparently it's as good as actually measuring it, if not better, because you can actually take the scanner to the actual item rather than actually bring the item off the machine.
That's the big benefit.
Well, you've got a big engine block. You don't want to be shifting that around.
Or on a gas.
Yeah.
A big sort of valves and things like that.
That's the big benefit too. And this brings us on to our next topic, really.
We haven't finished, Joe.
Are you topic leader, are you?
Okay, well.
It's a lot of topics.
That is the big advantage then of the other big advantage. You get a point cloud. So when you on the CMM, you have to probe each individual part of the surface, don't you?
Yep.
I know there's newer technology.
You normally have probing points, don't you? You put
exactly.
the stickers on, yeah.
But a handy scan, you get what's essentially you can create a 3D model called a point cloud, and that can go into your CAM for reverse engineering. That can go into your CAM to change. Maybe it's an existing tool you haven't got a drawing, but it needs modifying, new car, whatever. You scan it, put it into the CAM, remachine it. So to me, that's a big advantage. But for actually just stood there inspecting parts, it's not what I see currently. Okay. But that's only my opinion.
Could I throw something else into the mix? Recently, I took a day with Mark Irving, who's the northern.
How is he?
Northern South.
How is Mark?
He's a lovely guy. Yeah. Really knowledgeable. I will do. Does a lot of running, by the way. But
away from you, I should imagine.
I would have thought so. Yeah, but he took me into one of his customers that I shouldn't mention, but talking about their equator system. Now, the equator system, the 300 or 500, is
that's that spider thing, isn't it?
Yeah. Well, if you want to call it that, yeah. But
really technical there. It looks like a spider.
It's there to actually measure certain parts on the shop floor without, from a CMM point of view. Obviously, they can't be too large because you need a big CMM for that. But they're talking about actually calibrating the software, calibrating the temperature, blah blah blah. To make sure that you're taking a bat, sort of 1 in 10 off a batch run, for instance, and doing it on the shop floor. So that spindle keeps turning, basically.
That's interesting as well, though. You say 1 in 10. We're out at Mellish Engineering in Birmingham, Walsall, sort of
Midlands.
That'll do.
Warsaw.
They get very upset if you say Black Country. Anyway, moving on swiftly. They are experts in nuts and bolts, oil and gas.
Nuts about bolts?
No, just nuts about nuts. But they are one of the only 22, I think, in the world with the and we had to check this earlier, API accreditation. And if that's the wrong accreditation, I do apologise. But
is that an Americanism?
It is, yeah. So
American Petroleum Institute.
Oh, there you go. 3 in the UK, 7 in Europe, 22 in the world.
Google's been a friend to you this morning.
Yes.
Sorry? I can't Google that fast. Blimey heck.
But
hey,
inspection, they have to do essentially 100% of their parts need to be inspected for the.
So how many in 10's that?
11. So, but obviously for traceability, etc., certificates of conformity, if I can say that. So that was starting to be a blockage. They've got a scanner, essentially not CMM, and it's doing these parts.
I got to say,
micron tolerances.
I got to say, I think the way that the market has changed in looking at measurement and inspection has probably been led by areas like space technology, aerospace, automotive, because of traceability. Yep. Therefore, if you've got, unfortunately, it does happen. Let's say an aircraft that has a failure of a part. You need to know when it was made, okay, and basically make sure that it's not just about part of the wing, for instance. It's something specific that has been manufactured incorrectly, and that's what the traceability side is.
Absolutely. Yeah, we need that when we get on a plane, don't we?
Oh, yeah, I know you love going on planes, Joe.
Yeah.
That's only because of the free booze and food. Moving on, though.
No, it's tranquilisers to get on the plane.
Next step maybe in the equation, you've got 3D printing is coming to much more popular now, additive manufacturing, whatever you want to call it. I know Zeiss, as an example, have a CT scanner. So you go into hospital, not with your billet, with your broken leg, whatever they do, the CT scan. They're doing that on parts now, so they can check the internal construction.
That's getting on. The University of Nottingham have got one. £1 million.
Really?
Yeah, taxpayers' money.
Did it look inside your head?
No, couldn't find anything. But it's but you're absolutely right. They actually check the structure of the material. Yeah. They actually do it prior to machining and post machining. So is the material good enough to standard to machine? And after it, has there been any thermal breakages? Yep. And absolutely. And again, that's for our friends flying in the sky.
And you look at aerospace. I mean,
where else would they fly?
You look
just asking.
You look at some, a lot of the planes are made from more of composite material rather than metallic. So therefore, how do you find things like stress fractures? And that's where metrology has
no idea.
Or do I really? But
you're stressing me out.
What I'm saying is that you can't necessarily see it, but actually having very good measurement or inspection software that can actually analyze composite structures, which there is a lot out there, is crucial to those.
Does that take away then from NDT, non-destructive testing? Again, if I could say that, where you got the magnetic particles, the ultraviolet, and things like that. Will it take away from that?
Probably not.
I don't know. That's a generational thing, because what you find is on an aircraft.
Calling me old.
Yeah, on an aircraft, if there's something put in place, it's in place for that lifetime, like aircraft. And some of these planes have been around 50 years nearly. So you'll find, you go up to like Arnold Rags up in Sheffield, they do some quite antiquated inspection, but they can't inspect it any other way. They've actually got equipment to inspect it better, but because it's not part of the sealed route process, they can't do it. So
blast from the past. We like those.
Very
popular.
Yeah, no, exactly.
But when you come back to things like CMMs, for instance, talking about Renishaw, they've got the Revo head, where you effectively, if you've got quite a complex component, let's say for motorsport, let's say, and you need to get inside some of those areas which have taken hours to cut. The Revo system is there to actually angle. So therefore, a lot of standard probes, they can't get into some of the.
So I'm thinking they're normally generally they're 3-axis, but the Revo is going to be a 5-axis simultaneous.
Yeah, I mean, it does give you that capability of actually, measuring a component that is not, it's very bespoke. It's not, you're not sort of making tens of thousands of them. You're making one part, and it has to be crucially correct, especially in a Formula One car, for instance.
Yeah. Talk Formula One. What do you think of Melbourne on Sunday? I don't want to date it, but hey ho. Moving on swiftly.
Thrill for Bottas, if I'm honest with you. He's always played second fiddle to Hamilton, really.
Anyway, enough of that Formula One stuff. Anyway, software. What about software on CMMs and scanners, etc.? Any views? Any thoughts?
Yeah. Well, for me, let me have a go on this.
It's Joe's turn.
Bloom Nova Tests, they've got, obviously, for lasers and probes and a few other products, but lasers and probes predominantly. They've come up with a product called a Digilog. Digital, analog, Digilog. There's a clue. So digital, it's either, as we know,
it's good.
It's either on or off. It's yes or no. Okay. So when you're probing, it's yes or no. So and it takes the measurement from there. With digital, you can pick up a number of variables. So you can actually, rather than just inspecting the diameter or is that part present? Yes, it is. No, it's not. That's your Digilog. You've got the benefit of both. So you can actually measure. You can measure products on the machine. Actual genuine measurements. You can measure surface finish, obviously hole diameters, features, and any number of things. And that also can interact with your machine tool. So the part's incorrect, so remachine, inspect it again. Yes, it's correct, all without human intervention. So
that's you've got your machine software and in the machine tool, whatever it might be, whether it's turned or milled or whatever, and that software will work with that in the machine rather than having to unload it.
Yeah, it'll do it all. And I can, in terms of automation, you need that, don't you? Because otherwise, you can make 100 bad parts.
Yeah.
So, and the big thing is you can't fix what you can't measure. So, what the point of the saying is, I think it's Henry Ford quote actually, but the point.
Not another one.
Huh?
I tell you what,
You're sponsored by Ford.
No, Henry
Hoover,
yeah.
But he just happened to be Ford as well. But yeah, no. Joking aside, it's all it's all part of it. Metrology. Where do you start and where do you finish? It's a vast area, isn't it?
Quite a new area is a bit of a punt actually. The MTD March issue. There's a fantastic feature in there from Alacona with Element 6. Element 6, if you don't know them, read the feature. They're an amazing company.
I'm waiting for the pun.
No, they're talking about they basically are making tooling products effectively, but testing the actual tool life to get it the best it can for certain manufacturers. However, Alacona have put a in-process system, a cobot system that's actually taking material to they've got an Akuma Genos lathe, I think it is, and effectively they're trying to make sure that they get the best element of that end tip to the actual. They're using cast iron, so it's really, really hard, and that they're actually trying to get to a point where they're near enough breaking it to get to the best material that you can for tooling inserts.
I'm still waiting for the pun.
But the point is in process measurement, Colin.
What's it measuring? Okay. I don't understand. What's it? Hardness is what?
Yeah, I mean it's basically like a vision system. So you're looking, as the actual tool gets hot, is what elements are changing that actual tool or that insert.
Is it 6?
Element 6.
Yeah.
No, that's just the company.
Oh
my God.
Anyway,
moving on.
I've got a question.
The feature anyway.
Okay. Yeah,
I've got a question.
Statistics. Have you been Google-tastic again, Joe?
No.
God,
Safari. No, I don't need Google for this one. Pros and cons and opinions on in-cycle measurements, so probing and lasers and what have you, against off the machine. So that could be a CMM, an arm measurement. I don't use the brand. There's a few.
Scanner. Would you call it scanner? The ones that, you got like a CMM, but it's just scanners.
Yeah, essentially on the machine, off the machine. Pros and cons, and which would you use? Colin?
Ooh, I would off the machine. I suppose larger batch runs where you can put them on load and relatively small parts. You can put them on your CMM, whatever it is. Do a whole load, nice and quick.
Yeah, maybe that's what. Yeah.
Well, you asked my opinion.
No, Mark.
He's very sensitive, isn't he?
No. Yeah.
For me, it's probably a CMM versus in process measurement. Let's say is more to do with the application or the actual end product.
Application specific.
I didn't say it. If you go, for instance, I've been to.
This is going to be like the big reveal on Scooby Doo when he takes his suit off. It's actually Geo, isn't it?
Oh my God!
Yeah, but I've grown a few inches. The point I was going to make is that going up to Scotland a couple of years ago with BTL, they make a lot of parts for the oil and gas sector. So big valves. I'm talking like sort of
big valve. I know
4 or 5. 4 or 5 ton parts. Okay, the only way
that's definitely big valve.
The only way to actually measure it is they've got one of the largest Mitutoyo CMMs. There's no way that you could actually in process that while it's been manufactured.
A CMM or scanner is a CMM.
No, it's a CMM.
It's one hell of a CMM.
It's a very large CMM.
So what happens if the machine's got a probe in it? If you can machine it, you can measure it or not?
Well, you're the engineer.
But
here,
then
so you answer your own question.
You probably measure it as going along, but then you're stopping the spindles turning because you're measuring.
Yeah, but you pretty much get.
And
this is the no. This is why I asked. So, to me, in cycle, there's less work in progress because if you take it off the machine without inspection, that is work in progress. Yeah. So it's not finished. You can't sell the part. If you do it inside the machine, inside cycle, when that comes off, that's been inspected. That's complete. Some people do use third party again, so go to another. They might measure 1 in 10, 1 in 100 on the CMM. So that's the big one. No work in progress. The part comes off complete. You've got to probe it to see if it's correct. If it's not, it changes and it re-machines it. And obviously the CMM, the downside to CMM, you could be in a queue. What happens if you're doing low batch work? You can't, the machine's down.
Wait, the CMM.
Yeah, but the CMM's a lot more efficient now. And I think if you're doing it in the machine,
what happens if it's lunchtime? What happens if he's inspecting something else? Do I just?
Well, if it's lunchtime for you, it'd be all day.
Yeah, exactly. So do I just presume? Do I just presume I can press
harsh.
and make another one, or do I allow my machine to stand idle?
Well, you can't. Yeah.
What do you do then if you can't measure it? So you see what I mean? There's pros and cons on both.
Absolutely. Application specific. I hate to say it.
I think from
Back to Geo.
I think from my point of view, it is that it's nice that I think a process like metrology and inspection has become more of an inline process with your machine. It's as important as the whole process, rather than left to the last minute. And what do you get?
I think CMM sitting in the corner not being used.
I think it's a given, isn't it?
Yeah.
Back in the day, it's I've got CMM, I've got probing, I've got whatever it may be. Whereas now it's kind of a given. The challenge always was you can't really sell it to the client. You can't say I'm going to charge you $5 to inspect the part I'm making for you, because they'll just say, well, it should be right anyway, shouldn't it? But
yeah, but you want that traceability, the certificate of conformity, etc. So I think so. So this is really measuring up, this podcast, isn't it?
Yeah, well.
Hey, it's going to finish. Timing.
Oh, well, is Google ringing him?
Yeah. Google for the last 5 minutes. John,
yeah,
what's going
exactly. On? No. Right, we'll wrap up there. I've got probably ending with more questions and answers. No,
I'm going to wrap up because I took control of this.
To be fair, it is
apologies.
It is his inspection.
Sorry.
On this one.
Anyway, let's wrap it up. Thanks very much. Bye. No, Mark. Thank you very much, Mark, aka Gio Albanese.
I don't
Joe
mind.
Reynolds.
It's a lot better looking than me, anyway.
Yeah, Tom Foolery, and obviously myself,
Face on
Colin
radio.
Griffiths. It's been an absolute delight for you to be with me today, and thank you very much. Podcast 15, metrology.
Have a great week.
Yeah.